Hello students, and welcome to the series of videos on series. And we'll start with the definition, and this is really more of a layman's definition than a precise mathematical definition. We'll get to the math definition later, but for now, this layman's terms will work just fine. So a series is basically the sum of a sequence or a partial sequence. Okay. For example, one of the things that we can do is say that if we have a sequence, 2, 4, 6, 8, well then the series would be 2 plus 4 plus 6 plus 8, and we can add this up. This is 20. Okay, so basically a series is a sequence, but then you take all those numbers and you add them up. Okay, and we can also have, let's look at another example. If you have a sequence that's like 3, 1, 1/3, 1/9, and this pattern continues on forever, the series then would just be 3 plus 1 plus 1/3 plus 1/9 plus dot 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 onwards forever. Okay. So let's look at an example now. And this problem asks us to find the sum of the first 100 integers. In other words, what's the sum of this series? 1 plus 2 plus 3 plus dot 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 all the way up to 100. Okay, so I take all the numbers from 1 to 100 and I add them up. And this is somewhat of a legend, so I'm not sure how true it is, but this is, I'll call this Gauss's problem. Okay. So the legend was that Friedrich Gauss, who's a famous mathematician, when he was a young boy, maybe 12 or 13 years old, his teacher gave him this problem, thinking that it was going to take him a long time to add them up manually before a calculator, and it turns out it took him, just a few seconds to do this. And so what I really recommend you try and do is pause this video here, try to figure this out on your own, and then hit play and see if your solution works, and then if your solution is superior to mine. Okay? And of course you can just keep on watching this, but I don't know how helpful it is going to be to you in terms of learning it. Okay. So let me show you what Gauss did. So what we did here is he regroup into pairs. So he took 1 and 100 and he put them together. Then he took 2 and 99 and he put them together. And he took 3 and 98 and put those together. And if you notice, all of these pairs have a sum of 101. Okay. So he regrouped into pairs, and eventually he's going to stop at 50 plus 51. Okay. And you have 50 pairs, because originally you had 100 numbers, and even when you put them into pairs, you got half as many pairs. Okay. Each with a sum of 101. Okay. So then in total, well, it's just 50 times 101, which is 5,050. And so this is how Gauss was able to do this so quickly, but just by looking at this and rethinking the problem and grouping it again. Now, this method is actually a really great method, and we'll kind of see this in the next example here when we see something that's a little bit more complicated than this problem. Okay, so here I have a question that says find the sum of the first 271 multiples of 3. So this series is 3 plus 6 plus 9 plus dot dot dot, and I don't know how far this goes on, but it's going to go on to have 271 terms. Okay. And so let's think about how do we solve this. Well, what we noticed about the previous series up here, Gauss's problem, is that there's a clear end in here. We don't know what the clear end is here, so we need to figure that out first. Okay? And this isn't too difficult to figure out. This is the first term is 3, the second term is 3 times 2, the third term is 3 times 3, so the 271st term must be 3 times 271. I'll write it on the side here actually. 3 times 271, which is 813. Okay, so, oops, this is so messy. You want to go from 3 to 813. Okay. And we can try and see Gauss's method here. Does it still work? Well, we can take 3 and add to 813. The next number is going to be 6, and the second to last number is going to be 810. Okay. And then 9 plus 807, dot, dot, dot. And this is going to go on for quite a while. And now, how many pairs do we have? Well, this is somewhat of a tricky thing because you have an odd number of terms here. So you're going to have some pairs with stuff left over. But it turns out that middle number isn't going to be that problematic anyways. Okay? And I suggest you try to figure out for yourself, what is the middle number? What is the middle term? So I'll leave this to you to figure out on your own. But when we do this, we're going to have 135 and a half pairs. Okay? And usually when we talk about integers, halves, things like that are problems. But here we're talking about pairs. So half of a pair is just one number. Okay? So, and then each with a sum of 816. So in total, we have 135.5 times 816. And that gives us 110,568. Okay? And so we see here that this method that Gauss had when he was a young boy actually works quite well for other arithmetic series. Okay. Okay, so we'll end this here. This is basically kind of an introduction into series and what they are and how we can find some basic series, the sum of a few of these. In the next set of videos, you'll be able to see some of the more complicated examples. What do we do when we get to a geometric series? What happens when there's an infinite number of terms? Does it even make sense to add that? But that's for the next set of videos. Okay, thank you for watching. Be sure to watch the next ones. Have a wonderful day.